Okay, y'all. So I realized that people who weren't in class today probably don't know how to do the assignment, so here we are talking about supplementary angles and complementary angles. So these two terms are used to refer to when two or more angles do a certain thing and they add up to a certain number. And those two numbers are different for supplementary versus complementary, and those are the special names we have for these very particular moments with angles. If you notice, on the two on the left equal up to 180 when you add them. If you have 130 plus 50, that gives you a total of 180 degrees. This means that these two angles are supplementary. That's what supplementary means. It adds up to 180 degrees. You also have these two angles down here, 60 and 120, which also give you a total of 180 degrees. These are also supplementary, just in a different way. Now, the difference between those two sets, the top one, if you notice, these two lines, or these two angles, share a common line. They share this one. By having that common line, this makes these two angles also adjacent, and that word is spelled like so. They are adjacent, means they share a line. They are next to each other. The two lines, the two angles at the bottom are supplementary, the apt 180, but they are not adjacent. They're not sharing a line. They're not touching. Okay, so that's what supplementary is. We'll go over some examples of that in a second. Complementary angles, very similar situation, but they add up to a different number. They add up to 90 degrees. 60 plus 30 gives us 90 degrees. A telltale sign of this is when you see two angles that have a little red box in the corner. It'll be much smaller than this. It's just an exaggerated example, because this is what's called a right angle. When you see a right angle, that means it is 90 degrees, and so you can extrapolate some information from that. Ones at the bottom are also complementary. 27 plus 63 is 90. But they are not creating a right angle because, once again, just like the one on the left, these are not adjacent. The 60 and 30 here were adjacent, and together they make a right angle. But the ones at the bottom are not adjacent, but they are complementary. Okay. Now, next thing. You have here a very common situation in middle years math, where you have a straight line and then a line or line segment cutting that into two separate angles. If you notice down here, and I'll type this, this is a straight line. This always equals 180 degrees. Always, 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 always. The reason for that, if I have a circle, you probably heard the circle at 360 degrees. If you do a 360, it means you are turning all the way around. So that if that whole thing is 360, and I just split it in half, aka make a straight line, that would make that 180 degrees. So this is 180, the whole thing down here. Let's say I say that this is 120 degrees right here, and this is x. Now, there are lots of ways to figure out what that missing angle is. The most consistent way is to do the following. You set 180 equal to the total, because that's what the two angles are together. Now you have two angles, 120 and x. You can then subtract using a one-step equation, and you get 60, which is x. So this angle must equal 60 degrees. I'll just do 180, know the total, minus the 120, and get 60. Do it that way. Now, well, of course, they get more complicated, like so. We have 2x plus 10 over here, and 50. This is obviously more complicated. But the method works the same way. We know the total, since it's a straight line, has to be 180 degrees, which is consisting of two angles. The first one is 2x plus 10, and the second one is 50. Now, there are actually two ways to do this, and I'll try to do both. I'll just set up the same equation twice so I can show you both ways that I do it. Try to squeeze it in here. It's barely over. It's fine. So the first way is to combine like terms. I'll combine the positive 10 and the positive 50. They're both numbers. There's no x on them. So that would be 2x plus now 60 equals that 180. Then I can subtract 60 from both sides using a two-step equation format. So I have 120 equals 2x divided by 2. So x should equal 60. Cool. That's method one. Method two, which is how a lot of people do it, they kind of do it in their brain and in pieces. This is actually where my brain goes automatically. They just chip away at this thing. they know that they can take this 50 away from both sides and get 130. What this is essentially saying is that this entire angle over here is going to be 130 degrees, which makes sense. 180 minus the 50 is 130. Now it's a matter of figuring out what x is, because you know this is 130. He's got to chip away at it. So two-step equation format. I'll just subtract 10. I don't know why it's not writing. I've been doing this a lot lately. Very odd. Minus 10. There we go. You get 120 equals 2x. And then you can divide by 2, just like you did on the other side. And x should equal 60, just like it was in green on the left. Now, if the problem is asking for x, great. There it is. X equals 60. If it's asking for the angle, two ways to do that. You can either do it the short way, figure, okay, this was 50, therefore this whole thing, and I'll do it in red again, had to be 130. That makes sense. 180 minus 50. Or you can take your answer that you got, 60, and plug it into what you knew that angle was. You knew that angle was 2x plus 10. So you plug in 60 right there. So that becomes 2 times 60 plus 10. That's 120 plus 10, which is 130 degrees, which is what we got there anyway. So depending on what it's asking for, if it's asking for x, great, solve for x. If it's asking for the angle, you either got to think about it a different way or do a little bit of extra work at the end. Okay, thanks.